Welcome to our first video of this series on how to perform supervised classification using ERDAS IMAGINE. In this video, we will cover the steps involved in the collection of signatures or training samples to be used for the supervised classification. Training samples are groups of pixels that represent what can be recognized as a distinct pattern or potential class. Training samples must be a true representative of the desired output classes. The selection of the training samples depends largely upon the analyst's knowledge of the data, of the study area, and of the desired classes. ERDAS IMAGINE allows the analyst to capture parametric and non-parametric signatures. A parametric signature is based on statistical parameters. Non-parametric signatures are based on discrete objects in a feature space image and not statistics. In ERDAS IMAGINE, training samples can be captured using one or more of the following methods: digitized polygon vector layer, user-defined polygon, seed pixels, thematic raster layer from an image file of the same area. This could be a result of an unsupervised classification process. In this phase, we will use the seed pixel and the user-defined polygon methods for both parametric signatures. Let us begin. We will start by loading the imagery we want to classify into the ERDAS IMAGINE viewer. In this demonstration, we'll be using Landsat 8 imagery covering part of South Africa's Western Cape province. The image was acquired in October 2017. The image will display using the band combination specified in the preferences. In this case, my preferred combination is 652 to enhance agricultural land mapping. The analyst can change to a desired band combination. From the Raster tab, under the Classification group, select Supervised, then Signature Editor. Signatures are specific areas to which you assign a name for supervised classification. For example, in a parcel of land you may want to identify the forested areas, the water areas, and the soil areas. Right-click in the viewer containing your imagery and select New AOI layer from the menu. Notice that a new AOI layer is added into the contents pane. Now we will zoom onto a distinct light green area in the image. With a 652 Landsat 8 composite, light green represents agricultural fields or very healthy vegetation. The analyst can change to a different combination to identify other classes. From the Drawings tab, click on the polygon icon and draw a polygon around the green area. Make sure that the AOI feature we have just drawn is selected in the viewer. When selected, the AOI control handles are visible. In Signature Editor, click Create New Signature from AOI icon, or select Edit, then Add, to add this AOI as a signature. Notice that a new row is created, with a corresponding Class 1 signature name and color of the selected AOI element. In the Signature Editor, click inside Signature Name column for the signature you just added. Change the class name to an appropriate name for the type of class you highlighted, for example Agriculture 1 or Built-Up Areas, then press Enter on the keyboard. In Signature Editor, click on the color field next to the name and select a suitable color to use for that signature. Repeat these steps for several signatures that can easily be collected by digitizing polygons. When areas of interest have complex shapes, such that it would be time-consuming to digitize a polygon, create the AOI elements by growing a region of similar pixels. From the Home tab, under the Information group, click on Inquire to expose the menu. Select Inquire. The Inquire cursor is added to the 2D viewer, and the associated Inquire cursor dialog is open. The Inquire cursor dialog maintains a history of recently entered coordinates. In the 2D viewer, move the Inquire cursor to a pixel that is representative of the ground cover of interest. Click on the AOI layer from the Contents pane to make it active. Click on the Drawing tab, and from the Grow menu, select Growing Properties to open the Region Growing Properties dialog. Specify the neighborhood search method, either 4 pixels above, below, left and right, or all 8 neighboring pixels. Click on @Inquire, and notice that a region is drawn around the pixel representing that class. If the AOI is too small, the analyst will simply adjust the Euclidean distance value higher, or lower if the AOI is too big. If you change the Euclidean distance value, click Redo to see how this modifies the AOI element. Next, click on the Options tab in the Region Growing Properties dialog and check Include Island Polygons checkbox to display island polygons. Island polygons are areas within the region that do not match the region growing properties. When checked, island polygons are excluded from subsequent processing using their parent AOI, such as area calculation. When satisfied with the AOI, click the Create New Signature from AOI icon in the Signature Editor to add this AOI as a signature and rename it accordingly. Capture more signature samples for other desired classes. Close the Region Growing Properties dialog when done capturing. For the purposes of this demonstration, I will load a signature file I had captured prior to recording this video. Now that we have all the parametric signatures collected, save the AOI layer containing the signature elements by right-clicking on the AOI layer in the Contents panel and clicking Save Layer As. Navigate to a directory to store the AOI file and give it a suitable name. We also save the signature file by clicking File, then Save As from Signature Editor menu bar. Click OK in the Save Signature File As dialog. That's it for this phase on collecting signatures for Supervised Classification at ERDAS IMAGINE. In our next video, we'll go through the signature evaluation phase. Remember to subscribe to the channel and hit on the bell icon to get automatic notifications every time we upload a new video to our channel or to this series.